Hello everyone and welcome to Sally in Bytes. Today, I am here to teach Functions in Python, Part 2, for the class 12 students of Computer Science. In this video, we are going to learn modules, importing modules in a Python program, math module, and random modules. So let's dive in and get started. In Python, a module is a file containing Python code that defines functions, classes, and variables that can be used in other programs. The set of functions stored in a file is called module, and this approach is known as modularization. Modules help organize code and promote code reusability. They allow you to break your program into smaller, more manageable parts. There are some commonly used modules in Python that are used for certain predefined tasks, and they are called libraries. Let's discuss about module creation. You can create your own modules by writing Python code in a .py file. Each file represents a module, and its name is usually the same as the file name, excluding the .py extension. A module in Python is a file that contains a collection of related functions. To use a module in your program, you need to import it. Python provides import keyword to import modules in a program. You can import the whole module or specific parts of it. The import statement is used for importing modules. There are two methods to import modules: importing entire module and importing selective methods from a module. Let's see one by one in detail. Importing entire module. To import an entire module in Python, you can use the import statement followed by the name of the module. Syntax is import module_name. For example, let's say you have a module called math.py that contains various mathematical operations. To import the entire module, you would use import math. It gives access to all the functions of math module. Next is to import multiple modules in a program. Syntax is import module_name1, module_name2, and so on. Example: import math, time. This will import two modules in a program. Next is, we can access any function of the imported module by using dot notation. Example: math.sqrt function. Importing the entire module may load more code into memory than necessary. If you only need specific functions or variables from a module, you can use the from statement to import them selectively. Now, let's discuss about importing selective methods from a module. To import selective methods or entities from a module in Python, you can use the from statement. This allows you to import all or specific functions, classes, or variables directly into your code without referencing the module name. Syntax is from module name import star. Example: from math import star. It gives access to all the functions of math module. Next is to import a particular function of the module. Syntax is from module name import method name. Example: from math import sqrt. This will import only sqrt function from the math module. Next is to import multiple functions. Syntax is from module name import method1, method2, up to method n. Example: from math import sqrt, pow, pi. This will import multiple functions, that is, sqrt, pow, and pi functions of math module in a program. Let's see some examples. Line 1 imports the sqrt, pow, and pi entities from the math module. Now you can use these entities directly in your code without referencing the module name, math. In line 2, the sqrt function is imported from the math module, allowing you to calculate the square root of a number. In this line, it calculates the square root of 625, which is 25.0, and printed. In line 3, the pi constant is imported from the math module. It represents the mathematical constant pi. In this line, it is printed after rounding it to 2 decimal places using the round function. The output will be 3.14, which is the rounded value of pi. In line 4, the pow function is imported from the math module, allowing you to calculate the power of a number. In this line, it calculates 3 raised to the power of 3, which is 27 and printed. To import all methods from a module. Syntax is, from module name import star. It imports all the functions and constants from a module. Example. From math import star. This will import all the constants and functions or methods of math module. Let's see some examples. When you use from math import star, it imports all entities from the math module into your code. This includes functions, constants, and other entities defined in the math module. Look at line 1. This line imports all entities from the math module. It allows you to use any function, constant, or other entities from math without explicitly mentioning the module name. In line 2, the pi constant is part of the math module and represents the mathematical constant, pi. Since you imported all entities from the math module, you can directly access pi. The value of pi will be printed, which is approximately 3.141592653589793. In line 3, the factorial function is part of the math module. It calculates the factorial of a number. In this case, factorial of a5 calculates the factorial of 5, which is 120 and printed. In line 4, the sqrt function is also part of the math module. It calculates the square root of a number. In this line, sqrt of 225 calculates the square root of 225, which is 15.0 and printed. Let's see the key points of import statement. Import statement is the simplest and the most common way to use modules in our code. For example, import math. On executing this statement, Python shall perform 3 operations. Search for the file, math.py. Create space where module's definition and variable will be created. Execute the statements in the module. Import statement does not directly import the functions and constants in the program. To access or use any of the functions present in the imported module, we have to specify the name of the module followed by the name of the function, separated by a dot, also known as a period. This format is called dot notation. Let's see this example. Line 1 imports the math module, which is a standard library module in Python that provides various mathematical functions and constants. Line 2, the sqrt function is part of the math module. It calculates the square root of a number. In this line, math.sqrt of 144 calculates the square root of 144, which is 12.0, and printed. Let's discuss about the math module. The math module in Python is a built-in module that provides various mathematical operations and functions. It allows you to perform complex mathematical calculations easily. To use the math module, you need to import it into your Python script using the following line of code. Import math. This is the very first statement to be given. Let's discuss about the given function one by one. The math.ceil of x function in Python returns the smallest integer greater than or equal to the given number x. It rounds the number up to the nearest integer. Let's see these examples. In line 1, the import math statement imports the math module, allowing you to access its functions and constants in your code. In line 2 and 3, the math.ceil function is called with the argument -25.17. This function returns the smallest integer greater than or equal to -25.17, which is -25 and is printed to the console. In line 4 and 5, the math.ceil function is called with the argument -200.12. The function returns the smallest integer greater than or equal to minus 200.12, which is minus 200 and is printed to the console. In line 6 and 7, the math.ceil function is called with the argument minus 200.72. The function returns the smallest integer greater than or equal to minus 200.72, which is minus 200 and is printed to the console. In line 8 and 9, in this last example, the math.ceil function is called with the argument 200. Since 200 is an integer, the math.ceil function simply returns the same integer value 200 and is printed to the console. The math.floor of x function in Python returns the largest integer less than or equal to the given number x. It rounds the number down to the nearest integer. Let's see these examples. In line 1, the import math statement imports the math module, allowing you to access its functions and constants in your code. In line 2 and 3, the math.floor function is called with the argument minus 25.17. This function returns the largest integer less than or equal to minus 25.17, which is minus 26 and is printed to the console. In line 4 and 5, the math.floor function is called with the argument minus 200.12. The function returns the largest integer less than or equal to minus 200.12, which is minus 201 and is printed to the console. In line 6 and 7, the math.floor function is called with the argument minus 200.72. The function returns the largest integer less than or equal to minus 200.72, which is minus 201 and is printed to the console. In line 8 and 9, the math.floor function is called with the argument 200. Since 200 is an integer, this function simply returns the same integer value 200 and is printed to the console. The pow function in Python is used to calculate the power of a number. It takes two arguments, the base number and the exponent. It returns the output in floating point number. Syntax is pow of base comma exponent. The pow function returns the result of raising the base to the power of the exponent. It is equivalent to using the exponentiation operator. Let's see some examples. In line 1, the import math statement in Python is used to import the math module, which provides a set of mathematical functions and constants. In line 2, this statement calculates 2 raised to the power of 2 using the pow function from the math module. The result is 4, and it is printed to the console. In line 3, this statement calculates 10 raised to the power of minus 2. The pow function supports both positive and negative exponents. In this case, 10 raised to the power of minus 2 is equal to 0.01 and is printed. In line 4, this statement calculates 4 raised to the power of 2, resulting in 16.0, and is printed to the console. In line 5, this statement calculates 5 raised to the power of 0. Any number raised to the power of 0 is always 1. Therefore, the result of this expression is 1, which is printed to the console. The fabs function in Python is a built-in function provided by the math module. It is used to return the absolute value, positive value, of the expression or number. It returns a floating point number, even if the argument is an integer. Now, look at this example. In line 1, the import math statement in Python is used to import the math module, which provides a set of mathematical functions and constants. In line 2, math.fabs of number returns the absolute value of the variable number, which is minus 25. The result is then printed, giving us the output 25.0. Let's see the difference between fabs and abs function. Data types. The fabs function is specifically designed to work with floating point numbers, while the abs function can handle both integers and floating point numbers. Module requirement. The fabs function is part of the math module, so you need to import the module using import math before you can use it. On the other hand, the abs function is a built-in function in Python, so you can use it without any imports. Return type. The fabs function always returns a floating point number, even if the input is an integer. In contrast, the abs function returns an integer if the input is an integer, and a floating point number if the input is a floating point number. The sqrt function in Python is used to calculate the square root of a number. This function accepts a number which is greater than 0, otherwise results in runtime error. It is available in the math module, so you need to import it before using the function. Let's see some examples. In line 1, the import math statement imports the math module, making all its functions and variables accessible in the current script. In line 2 and 3, we use the math.sqrt function to calculate the square root of 16. The output is 4.0. In line 4 and 5, we calculate the square root of 22 using math.sqrt of 22, and the output will be 4.69041575982343. In line 6 and 7, we calculate the square root of 22 using math.sqrt of 22, and then apply the round function to round the result to the nearest integer. The rounded value, which is 5, is printed on the console. In line 8 and 9, when trying to calculate the square root of a negative number, such as -22, an error occurs because the square root of a negative number is not defined in the real number system. This will result in a value error being raised. The log10 function in Python is used to calculate the logarithm base 10 of a number. It is available in the math module, so you need to import it before using the function. Let's see some examples. In line 1, the import math statement imports the math module, making its functions and variables accessible in the current script. In line 2 and 3, we calculate the logarithm base 10 of 100 using math.log10 of 100. The result, which is 2.0, is printed on the console. In line 4 and 5, we calculate the logarithm base 10 of 100.42 using math.log10 of 100.42, and the output is 2.00182021703838, is printed on the console. In both cases, the math.log10 function takes the argument as the number for which you want to calculate the logarithm base 10. It returns a floating point number representing the logarithm base 10 of the given number. The cos function in Python is used to calculate the cosine of an angle given in radians. It is available in the math module, so you need to import it before using the function. Let's see some examples. In this code, we calculate the cosine of different angles using the math.cos function and print the results. In line 2 and 3, we calculate the cosine of 0 radians, or 0 degrees, using math.cos of 0. The result will be 1.0, as the cosine of 0 degrees is 1. In line 4 and 5, we calculate the cosine of 30 degrees using math.cos of 30. The argument is in degrees, but the math.cos function expects the angle in radians. So, internally, the value is converted to radians. The result will be approximately 0.15425144988758405. In line 6 and 7, we calculate the cosine of -3 radians using math.cos of -3. The result will be approximately -0.98999249660044454. Negative angles are allowed, and the math.cos function will calculate the cosine accordingly. In line 8 and 9, we calculate the cosine of pi radians using math.cos of math.pi. The result will be -1.0. The sine function in Python is used to calculate the sine of an angle given in radians. It is available in the math module, so you need to import it before using the function. Let's see some examples. In this code, we calculate the sine of different angles using the math.sine function and print the results. In line 2 and 3, we calculate the sine of 0 radians, or 0 degrees, using math.sine of 0. The result will be 0.0, as the sine of 0 degrees is 0. In line 4 and 5, we calculate the sine of 30 degrees using math.sine of 30. The argument is in degrees, but the math.sine function expects the angle in radians. So, internally, the value is converted to radians. The result will be minus 0.98803162409286818. In line 6 and 7, we calculate the sine of minus 3 radians using math.sine of minus 3. The result will be approximately minus 0.141120008059867. Negative angles are allowed, and the math.sine function will calculate the sine accordingly. The tan function in Python is used to calculate the tangent of an angle given in radians. It is available in the math module, so you need to import it before using the function. Let's see some examples. In this code, we calculate the tangent of different angles using the math.tan function and print the results. In line 2 and 3, we calculate the tangent of 0 radians, or 0 degrees, using math.tan of 0. The result will be 0.0, as the tangent of 0 degrees is 0. In line 4 and 5, we calculate the tangent of 3 radians using math.tan of 3. The result will be minus 0.14254654307427778. In line 6 and 7, we calculate the tangent of minus 3 radians using math.tan of minus 3. The result will be approximately 0.14254654307427778. The help function in Python is used to access the built-in documentation, docstring, of a particular object, module, function, or class. It displays information about the object and how to use it. Now, look at this example. When you run this code, the documentation for the math.tan function will be displayed in the console or interactive shell. It will provide information about the function's purpose, parameters, and usage. Note that the help function returns the documentation as a string, so you need to use print to display it. Now, let's see about the random module. The random module is like a magical tool that helps us create randomness and surprises in our programs. Generating random numbers. Just like rolling a dice and getting a random number between 1 and 6, the random module helps us generate random numbers in our programs. We can use these numbers to make computer games more exciting or make decisions in our programs. Picking random things. Imagine you have a jar filled with different colored candies. The random module can help us pick a random candy from the jar. We can use this to create surprises in our programs, like picking a random character in a game or a random question in a quiz. Shuffling things. Think of a deck of playing cards. The random module can help us shuffle the cards so that they are in a random order. We can use this to create random sequences or mix up things in our programs. Pseudo-random numbers on lottery scratch cards. ReCAPTCHA, like in login forms, use a random number generator to define which image is to be shown to the user. In Python, random numbers are not enabled implicitly. Therefore, we need to invoke random module or random code library explicitly in order to generate random numbers. The first statement to be given in a program for generating random numbers is import random. Let's see the various functions associated with the random module. The randrange function is a part of the random module in Python. It allows us to generate a random number from a specified range. This method generates an integer between its lower and upper arguments. By default, the lower argument is 0 and upper argument is range -1. The syntax is random.randrange of start, stop, step. The randrange function takes in 3 parameters. Start, optional. It specifies the starting point of the range, inclusive. If not provided, it defaults to 0. Next parameter is stop. It specifies the ending point of the range, exclusive. The function will generate random numbers up to, but not including, this value. Step, optional. It specifies the step size or interval between numbers in the range. If not provided, it defaults to 1. The start, stop, and step values can be integers. Let's see an example. In line 1, the import random is used to bring the random module into our code. By importing the random module, we gain access to various functions and capabilities that allow us to work with random numbers and randomness in our program. In line 4, we are using the randrange function from the random module. The randrange function generates a random number within a specified range. The first parameter, 0, specifies the starting point of the range, inclusive. In this case, we want our range to start at 0. The second parameter, 10, specifies the ending point of the range, exclusive. We want our range to go up to, but not include, 10. The third parameter, 2, is the step size or interval between numbers. It indicates that we want to generate only even numbers within the range, as we are incrementing by 2 at each step. The randrange function will then produce a random even number between 0 and 10, exclusive, based on the specified range and step size. This random even number is assigned to the variable even_number. Finally, we use the print function to display the value stored in the even_number variable. The output will be the randomly generated even number between 0 and 10. Here, you can see the output displayed each time a random number, for the first code 4, for the second code 8, and for the third code 6. Let's see another example. In line 2, the line import random imports the random module into our code. This module provides functions that allow us to work with random numbers, make random selections, and more. In line 3, we define a list called subjects that contains 4 different subjects as elements. Each subject is represented by a string. In line 4 and 5, we use the randrange function from the random module. The randrange function generates a random number within a specified range. The first parameter, 2, specifies the ending point of the range, exclusive. Since we provide only one parameter, the starting point is assumed to be 0. The randrange function will then produce a random number between 0 and 2, exclusive. It could be either 0 or 1. The random number generated by randrange is assigned to the variable ran_index. This number will serve as the index to select a random subject from the subjects list. Finally, we use the print function to display the subject at the randomly chosen index in the subjects list. Since the ran_index variable holds a random number between 0 and 2, it will randomly select one of the subjects from the list. So, the overall code imports the random module, creates a list of subjects, generates a random index using randrange, and then prints the subject corresponding to the randomly chosen index. You can see the output that, each time the code is run, a different subject will be printed, adding an element of randomness to the program. The random function generates a random decimal number between 0 and 1. This function can be used to generate random floating point value in the range 0.1, 1.0. It takes no parameters and returns values uniformly distributed between 0 and 1. Including 0, but excluding 1. Let's see some examples. In this code, each time random function generates a different number. Program to calculate the sum of the digits of a random 3-digit number. This code generates a random number n between 100 and 1000, and then separates the digits of n to calculate the sum of its individual digits. Look at line 4. The random function generates a random fractional number from 0 to 1. When a random number generated using random function gets multiplied by 900, a random number is obtained from 0 to 899. When we add 100 to it, we get a number from 100 to 999. Line 7 and 8 converts the random number to an integer. Line 11, 12, and 13 extracts the individual digits from the random number. Line 16 and 17 calculates the sum of individual digits. When you run this code, it will output two numbers. The first number, n, is a random integer between 100 and 1000. The second number is the sum of the individual digits of n, that is, a plus b plus c. In this case, n is 547, and the sum of its digits, 5, 4, and 7, is 16. Next time when you run the code, n is 670, and the sum of its digits, 6, 7, and 0, is 13. The random function generates a random integer between a specified range. It is part of the random module in Python. Now, look at this example. In this code, randint of 1, 10 generates a random integer between 1 and 10, including both endpoints. Each time you run the code, it will output a different random number within the specified range. For example, the output could be 2 and the next time it could be 3 and so on. Let's learn some more functions of the random module. The uniform function is another function provided by the random module in Python. It generates a random floating point number between two specified values. The syntax is random.uniform of x, y. Now, look at this example. In this code, uniform of 0, 1 generates a random floating point number between 0 and 1. The range is inclusive of 0 but exclusive of 1. Each time you run the code, it will output a different random number within the specified range. You can see the output below. The choice function is another useful function provided by the random module in Python. It allows you to randomly select an element from a sequence, such as a list or a string. The syntax is random.choice of sequence. Let's see an example. You can also use the choice function with strings. In this case, choice of my_string selects a random character from the my_string string. The output could be any character from the string, such as R, next time it could be L, and so on. The shuffle function is another useful function provided by the random module in Python. It allows you to randomly shuffle the elements of a sequence, such as a list. The syntax is shuffle of list. Let's see an example. In this code, shuffle of my_list shuffles the elements of the my_list list in place, meaning it modifies the list directly. Each time you run the code, it will output a different order of the elements in the list. For example, the output could be list of elements 4, 3, 5, 1, 2, and next time it could be list of elements 3, 4, 2, 1, 5. The shuffle function is particularly useful when you want to randomize the order of a list or when you need to randomly permute a sequence of elements. It can be handy for implementing algorithms like shuffling a deck of cards, randomizing quiz questions, or generating random permutations. Thanks for watching. Watch the upcoming videos. Functions in Python Part 3. User-defined functions, how function returns a value, parameters and arguments in functions. You can check the link in the description box below.